Today we are doing lesson 2.1, rational numbers. Our I can statements today, I can use the long division to convert a rational number to a decimal. And I know that a rational number in decimal form ends in 0 or eventually repeats. All right, so let's go ahead and take a look at what rational numbers are. So here we have a definition for a rational number. Rational number is a number that can be written like a fraction with two numbers, a over b, where a and b are integers and b does not equal 0. So anything that can be taken and written as a fraction is considered to be a rational number. So if you look over here, we have some different categories inside the smallest circle are whole numbers. Those are the numbers that you used for counting objects when you first learned to count. So 0, starting at 0, 0, 1, 2, 3, 4, 5, those are all whole numbers. Integers, this is a bigger circle here, include those whole numbers, 1, 2, 3, 4, 5, as well as their opposites, -1, -2, -3. So both -1 and +8 are considered integers, but 8 would be a whole number as well. And then all of the whole numbers and all of the integers also fall into the category of rational numbers, as well as things like 2/5 and -1 and 3/10 that are in decimal or fraction form. There are two different types of decimals that are considered rational number, and they're over here. So a terminating decimal is a decimal that ends, so 2 and 5/10, -3600, 12 and 875 thousandths. Those are terminating decimals. Repeating decimals are also considered rational numbers. So repeating decimals are a decimal that has a pattern that repeats. So 3.15 with the line over the 5, that bar notation, tells us that the 5 is the only number that repeats. 3.1555555 and so on. Here there's a bar over 24, so that's the part that repeats. 0.1242424 and so on. And then occasionally you'll see it written this way with the number that's repeating and then a ... to indicate that that pattern will continue. If you have something that is forever going on as a decimal and there's no pattern to it, then that is not a rational number. So one of our skills here is to take a rational number and write it as a decimal. So I have a couple examples that we'll walk through just looking at, and then we'll try it. So this first one, write -3/4 as a decimal. This fraction bar means divide. The problem is 3 divided by 4. And then our answer is going to be negative because this fraction is going to be negative. So the top number goes on the inside, 3, divided by 4. For the number you're dividing by, that denominator goes on the outside. So 3 divided by 4. You add a 0 and a decimal if that number doesn't go in. So here, 4 doesn't go into 3 a whole number of times. So we put a 0 and a decimal, and then we keep adding zeros until we've run out of numbers. So here, 4 doesn't go into 3, it does go into 30, and it goes in 7 times. 7 times 4 is 28. When you subtract, you get 2. We still have a remainder there, so you have to add a 0, bring it down, and continue to divide until your remainder is 0. All right, so our answer here was 75 hundredths, but because the original problem was a negative, our final answer is a negative as well. Okay, on this one, 2 and 5/6, you can do it a couple different ways. So the way that this example illustrates is to take your mixed number and make it into a improper fraction before you divide. So 2 and 5/6 means the same thing as 17/6. 6 times 2 is 12, plus 5 is 17. 17 goes on the inside, 6 goes on the outside. That number on the bottom denominator is going to be the number that's on the outside of your division. And then you divide the same way we did on the last problem. If the numerator is greater, that means you're going to have a number that has a value of more than one whole. So 6 goes into 17 2 times. 2 times 6 is 12. We subtract to get 5, and then since we have a remainder, we have to add a decimal, add a 0, bring it down. 6 goes into 50 8 times. 8 times 6 is 48. And then the division continues until you get to a number that ends, like 0, or a number that repeats. So here, that 2 repeats. When we did 20 minus 18, we got 2. We added a 0, got 18 again, and 2. So once you see that number repeating, you can add a little bar above it. The other way to do ones like this is to just convert the 5/6 part of the fraction. And then when you write your answer, you need to make sure that you put the 2 in front of it, 2 point, and then your answer for the 5/6. Okay, so let's go ahead and try a few problems. So example 1, I have -5/11. The top number goes on the inside, the bottom number goes on the outside. So this is 5 divided by 11, and my answer needs to be negative. Okay, so let's start. I'm going to put 5 on the inside. So 5 divided by 11 on the outside. I'm going to go ahead and put my negative sign up here where my answer is going to be, so I don't forget about it. Okay, 11 does not go into 5. So that means I need to add a 0 above my 5 and a decimal. And then a 0 and a decimal after my 5. So a decimal and then my 0. Send that out. Okay. 11 does go into 50. It goes in 4 times. 4 times 11 is 44. 50 minus 44 is 6. I still have a remainder. I haven't seen anything repeat yet, so I need to add a 0. I need to bring it down. Now I have 11 into 60. 11 goes into 65 times. 5 times 11 is 55. 60 minus 55 is 5. All right, and then if I go back and look, I started with just a regular 5. If I continue this division, I'm going to get a 5, and then I'm going to get a 6, and then I'm going to get a 5 and a 6. So both digits here are repeating. So that's my answer. I've got negative 45 hundredths repeating. All right, let's take a look at this next one. 7 and 3/8. So I'm going to go ahead and just do the 3/8 part of the division, and then when I write my answer, I'm going to make sure that 7 goes in the front. Okay, so 3/8. 3 goes on the inside. 8 goes on the outside. 3 divided by 8. Okay, so 8 does not go into 3 a whole amount of times. I'm going to put a 0 and a decimal. And a decimal and a 0. Okay, 8 does go into 30. It's going to go in 3 times. Okay, 3 times 8 is 24. 30 minus 24 is 6. Okay, got to keep going until either I see a number that repeats or I have a 0 as a remainder. 8 goes into 66, 7 times. 7 times 8 is 56. 60 minus 56 is 4. Still haven't seen a number that repeats or a 0 as a remainder, so I'm going to keep on adding my zeros. Okay, 8 does go into 40 a whole number of times, so that's great. That number is 5. 5 times 8 is 40. Okay, so I got all the way down to a remainder of 0. My decimal for 3/8 is 3 and 75. 375 thousandths, 0.375. That's not my answer for this one though, because I still have that whole number 7. That hasn't gone anywhere. I just didn't use it in my division problem. 7.375. So 7 and 375 thousandths. That's going to be my answer on this one. All right. And then let's look at this word problem. So it says, Sam bought 3 1/4 pounds of apples to make some apple pies. What is the rate of the apples written as a decimal? Okay, so I'm going to do the same thing. I'm going to change 1/4 into a decimal, and then I'm going to put it after the number 3. So 1/4, now that's what I call a benchmark fraction, so you might already know the decimal. But I'm going to go ahead and show the long division, just in case you don't know that decimal. All right, 4 does not go into 1 a whole number of times, so I'm going to put a 0, add a decimal. I've already added a decimal and a 0 here. Okay, so 4 into 10, that does work. It's 2 times. 2 times 4 is 8. 10 minus 8 is 2. Add a 0, bring it down. 4 goes into 25 times. 5 times 4 is 20. And now I've gotten to the point in my problem where I have 0 as a remainder. So my decimal for 1/4 is 25 hundredths. But my number is 3 1/4. So I need to put my 3 in my answer. 3 and 25 hundredths. And since this is a story problems always need a label. So let's see. Looks like that one, the label is going to be pounds. Okay. All right, so that was taking a fraction and writing it as a decimal. Now we're going to practice the opposite, which is taking a decimal and writing it as a fraction. So here we're writing negative 26 hundredths as a fraction in simplest form. Now if you listen to me read that, 26 hundredths, I say hundredths because this last digit is in the 0 on the hundredths place value. I have 2 digits there. All right, so I'm going to write 26 hundredths as a fraction. So if I ignore this decimal here and I just write the number on the top, that would be like a negative 26. If there's a 0 in the very front of that decimal, you can ignore it. And then I count how many decimal places. 1, 2 decimal places. That's going to be the same as the number of zeros in my denominator. 1, 2 decimal places, 1, 2, 0 here. Negative 26 over 100 means the same thing as negative 26 hundredths. Now here it asks me to do simplest form. So I need to think about if there are any common factors for negative 26 and 100. So what I mean by that is I'm looking for numbers that would divide evenly into both 26 and 100. So for 26, I know that's an even number, and I know 100 is an even number as well, which means both of those numbers can be divided by 2. So that's what I'm going to do. As long as you're dividing by the same number on both your numerator and your denominator, your fraction is going to stay the same value. Okay, negative 26 divided by 2, that's going to give me a negative 13. 100 divided by 2 is going to give me 50. Okay, 13 is a prime number. The only numbers that can go into it are 1 and 13. 1 goes into 50, but dividing by 1 is just going to give me the same number, 50. 13 does not go in. So this is my simplest form, negative 13 over 50. All right, so write the decimal as a fraction or a mixed number in simplest form. Go ahead and pause the video and try these 4 on your own. Okay, let's check our answer. So number 5, we've got 7 hundredths, negative 7 hundredths. 7 goes on the top. I still need that negative. And I think I said 7 hundredths when I was reading here. I should have said 7 tenths. That is negative 7 tenths. 1 decimal place, 1 0. Negative 7 over 10. I cannot simplify it. That is already in simplest form. All right, for this next one, for number 6, I've got 125 thousandths. 125 goes in my numerator. 1, 2, 3 decimals. I need a 1 with 3 zeros, which is 1,000. 125 1,000ths is how you say that number correctly. Now, I know that 5 can go into both of these. And I know that 25 can go into both of these. And I happen to know that 125 goes into both of them as well. But you could divide it in smaller groups if you wanted to. But I'm going to go ahead and just do it in one set since I happen to know that 125 goes into both. When I divide both numbers by 125, for simplest form here, I get 1/8. All right, number 7, negative 3 and 1/10. I'm going to leave that negative 3 as a negative 3. And then I'm going to change the decimal into a mixed number. 1/10 means 1 over 10. 1 decimal, 1 0. 1/10 is already simplest form, nothing else I can do to that. All right, and let's look at this next one. So -10 and 25/100. So -10, that part's staying the same. 25 over 100. 2 decimals, 2 zeros after the 1. Then I'm going to divide both my numerator and my denominator by 25. You could do divided by 5 and then divide by 5 again if you need to. And I'm going to get -10 and 1/4. All right, our next type of problem is looking at comparing two rational numbers. So I want to start by just talking about some of the ways that we can compare fractions. So 1/3 and 1/2, and there are lots of different ways that we could do that. Some people like to think about comparing with a picture. So if I'm thinking about a cookie or a pizza or something like this, and I make 3 equal slices, and I shade in 1, that represents 1/3. And I have 1/2. I could use my picture to show that 1/3 is less than 1/2. Remember, alligator eats the bigger number. That's less than 1/3 is less than 1/2. So using a picture, that's one strategy that you can do. Another strategy would be to make a common denominator. So if I was going to do that, let's see, for this one, I could do 6. So that's what I'm going to do. 1 times 2 is 2. 3 times 2 is 6. So 1/3 means the same thing as 2/6. Then over here I can say 1 times 3 is 3. And 2 times 3 is 6. All right, so 2/6 is less than 3/6. So common denominator works. You can change them into decimals if I do that work, and I'm just going to write the decimals here to save myself some time. 1/3 means 3/10 repeating. 1/2 is the same thing as 5/10. So those are 3 different strategies I could use. I could use pictures, I could use a common denominator, I could use equivalent fractions. Okay, let's take a look at this one. This one is a little harder to use the picture method because I have 5/8 and 4/10. Now I can still do pictures, but it's a little bit harder. For this one though, if I think about 5 compared to 8 and 4 compared to 10, I know that 5/8 is going to be more than 1/2. Because 1/2 of 8 would be 4/8. And I know 4/10 is less than 1/2. Because 1/2 of 10 would be 5/10. So since I know 5/8 is more than 1/2 and 4/10 is less than 1/2, I can know 5/8 is going to be greater than 4/10. I could do a common denominator again. Let's see, 8 and 10 both go into 40. So I could do that. 5 times 5 and 8 times 5. 5 times 5 is 25. 8 times 5 is 40. And here I would have to multiply by 4 to get it to be 40ths. 4 times 4 is 16. 10 times 4 is 40. Okay, so 25 40ths is going to be greater than 16 40ths. So those are a couple more strategies that I can use to compare those fractions. Here's a list of a lot of different ways that you can compare fractions. So you can find a common denominator and compare the numerators. If you happen to have the same numerators, you can compare the denominators. The larger the number in the denominator, the smaller the fraction. That's like here, 1/3, 1/2 have the same number on the top, but 1 out of 3 pieces would be smaller than 1 out of 2. So it'll work if you have the same numerator. You can compare your benchmark to your fraction to a benchmark, like we did in the last one, more than half or less than half. You can compare the missing piece if both fractions are one piece away from a whole. You can change it into decimals, you can draw a picture, you can put on a number line. All right, so for our problem here, it says the table shows the elevations of 4 sea creatures relative to sea level. Which of the sea creatures are deeper than the whale, and explain. Okay, so deeper than the whale means lower in value. So we need a strategy to compare these numbers that are in fraction form to our decimal from the whale. So when I have both fractions and decimals to compare with each other, usually the best strategy would be to change your fractions into decimals, and then you can compare them. If you've got just 2 fractions to compare, we can use those strategies that we just talked about. Okay, so we're going to go ahead and change these into decimals, and then we're going to compare them. This is a negative 13 tenths. So if I do, let's see, I'll do that work over here. 13 on the outside. Sorry, I said that wrong as I was writing it correctly. 13 on the inside, 10 on the outside. 10 does go into 13 one time. 1 times 10 is 10. 13 minus 10 is 3. Okay, I've got a remainder here, so I'm going to go ahead and just add a 0 and a decimal, add a decimal here. Okay, and I need to bring that down. 10 goes into 33 times. Okay, got my remainder of 0. Since I see it's negative over here, this is going to be a negative over here. I'm going to just rewrite my answer next to my problem, though. Here, negative 1 3/10. Okay. Then we'll look at this next one, negative 2 1/5. So I'm going to change the 1/5. I'm going to leave the negative 2 as a negative 2. 1/5 would be 1 divided by 5. 5 does not go into 1 a whole number of times. So I've added my zeros and my decimals. 5 does go into 10, it goes in twice. So negative 2 1/5 is really negative 2 2/10. And then the shark, negative 2/11. 2 on the inside, 11 on the outside. 11 does not go into 2. Does go into 20. Okay, so 11 goes into 20 once. I get 11. When I subtract, I get 9. All right, add a 0, bring it down. 11 goes into 98 times. So that would be 88. Now I have a 2, which is what I started with, which means these are going to repeat. And it was negative, so this is a negative. Okay, so I have my decimals here. Negative 1 3/10, negative 2 2/10, negative 1800ths. So which of the sea creatures are deeper than the whale? That's going to be these two, angler, fish, and squid. Because their value is less than negative 8/10. When we're comparing with negative numbers, the closer to 0, the larger the value. This one is only 1/10, a little bit more than 1/10 away from 0. This one's 8/10 away from 0. It is farther away. It is a lower value. Shark is closer to the ocean surface because that ocean surface would be 0. All right. Let's take a look at this one. The elevation of a dolphin is -1/10 kilometer. Which of the sea creatures in example 3 are deeper than the dolphin, and explain. Okay, go ahead and try this one. I'll put the screen back to the last one so you can see which ones are lower than 1/10. Okay, let's check our answer. So -1/10. When I do my work, 1 on the inside, 10 on the outside, 0 decimal, 0 decimal, 10 goes into 10 once. That's -1/10. That's what it looks like as a decimal. So which ones of them? All of them. Okay, so that's my explanation. All of them are lower than that -1/10. All right, and 2 last problems to try. Pause the video and try them on your own. Okay, let's check our answers. So I have -5/6 as a decimal. So I'm going to write -5. Actually, I'm just going to write 5 on the inside, 6 on the outside. I'm going to put my negative up here where my answer is going to be. 6 does not go into 5, so I add a 0 and a decimal, and a decimal and a 0. 6 does go into 50, and it goes in 8 times. 8 times 6 is 48. 50 minus 48 is 2. I need to keep going until either I see a repeating number or I have a remainder of 0. So I've got to keep going. All right, so 6 goes into 20 3 times. 3 times 6 is 18. I subtract to get 2 again. So I had 2 as an answer here. I have 2 as an answer here. That means my last number is going to be repeating. All right, so that's my decimal for -5/6, -83/100ths with the 3 repeating. And then our last one here, write -56/100ths as a fraction. Get rid of that decimal point and the 0. Just write it -56. 2 decimals. I'm going to put 2 zeros underneath it. 2 decimals, 2 zeros. Okay, so -56/100ths is written this way, and then I need to look to see what I can simplify it by. So it looks like both of these would be divisible by 2 because they're both even numbers. Okay, -56 divided by 2, that's going to give me -28. 100 divided by 2 is going to give me 50. Okay, so I am seeing that I have still 2 even numbers. So that means I need to keep on dividing. -28 divided by 2 is 14, so that's going to be a -14. 50 divided by 2 is 25. That's going to be my fraction in simplest form, -14/25.